We don't go for this. No, sir, what will happen if I take marginal rays? Okay, then you can see that you have to take help of the mathematics and you have to encounter. Okay, okay, let me give like a mathematics involved here. So some will take help of mass. Okay, I just took a paraxial marginal ray. So after reflection, so where do that? It will meet the principal axis at point B. So this will be called as, let's call it as a principal axis here after reflection. So what is alpha? Shall we write 180 minus 2 theta? The sum of in the triangle BMC. Theta plus alpha. Sum of all the angles should be equal to 180 degrees. So therefore, alpha is equal to pi, I'll write it. Pi minus 2 theta. And we know what is the distance, like MC should be equal to PC. And what it is equal to R, radius of curvature. What is R? R also let me define. It is called as radius of curvature. Then angle BCM, angle BCM BCM should be equal to BMC. Because of that, and it become isosceles triangle. So therefore, these two angles will be equal. So these two angles should be equal from the geometry. Then since what happened, like this distance BC should be equal to BM. Okay, fine. Okay, already we have derived earlier case that one, and MC should be equal to PC. Okay, keep this one here. Now let me apply the sine rule. So this BC, what we can write it as? BC is equal to, let me apply the sine rule for this particular triangle. This MC by sine alpha applying sine rule for triangle BMC. What do that sine rule tells? Let's say distance MC by sine alpha should be equal to distance BC by sine theta. Now what is MC? MC should be equal to R. Later on I'll write it. Sine alpha, sine pi minus 2 theta. Then they should be equal to BC by sine theta. I'm interested in the distance BC. BC is equal to sine theta by sine of pi minus 2 theta into BC. Sine of 180 minus theta, sine of 180 minus 2 theta should be sine 2 theta. So further expansion, sine 2 theta will become 2 sine theta cos theta BC. BC by 2 cos theta, or BC by 2 secant theta. Oh, MC, no, this is. I'll make correction. Yeah, thank you. What is MC? MC should be equal to R. MC should be equal to R. Further, distance BC equal to R by 2 secant theta. I'm interested in that distance PB. So this distance PB, what you can write it as PC minus BC. BC is what we have here. So what is PC? PC should be equal to R. And what is PB? PB will become focal length. We should not define. Okay, let's still let me call it. Call it a focal length R minus R by 2 secant theta. If theta very small. So look at this very important diagram. For different values of, for different angle, for different values of angle of incidence. You can see here, what is angle of incidence here? It will be theta 1. What is angle of incidence? Theta 2. So as the rays, what happen if they are, as the ray approaches close to the P, what will be this angle of incidence? This will decrease. I think I am, yeah. Very clearly I can show things. No. As the ray approaches close to the P, as the incident point lies close to the P, this angle of incidence should also decrease. You can see from here, if I bring the incident ray very close to the P, the theta will decrease. But therefore, so as angle of incidence increases, then it will become a marginal ray. So now why these two rays intersect at different points? There's a primary question. So why the blue color ray will intersect the pole principal axis here? Why the red color ray will intersect the principal axis at this point? What is the reason for that? I have a formula, no? What is the reason we can put it? The reason is what? This particular formula. So what this formula says? It depends upon the angle of incidence. No? This F I'm going to measure from the pole. Go this one. If theta very small, then secant theta will become 1. Then F will become R by 2. Then it will become a paraxial ray. But if the marginal ray, the different rays will intersect the principal axis at different points. So therefore, for marginal rays, the focus is undefined. Only for paraxial rays, it is defined here. For different values of theta, the marginal rays will intersect the principal axis at different points. I think as the angle of incidence varies, the reflected rays intersect the principal axis at different points. It will not pass through the focus. The focus is not defined itself here. Only for paraxial rays, the focus will be defined. I think better I should take out this word focus here. So the focus is defined only for paraxial rays. Got the idea now? This is so that angle of incidence should be very small and the point of incidence should also lie very close to the P. Then become paraxial rays. Got the idea? That the basic difference between marginal and paraxial rays. There's a very fundamental one. So possibility of asking such things. So you can take help of this mathematics. This one. So how do I come to know, sir, like it's a paraxial or marginal rays? In every problem, I'll do mention for paraxial rays. By default, it will be what all we discussed, the theoretical ideas, everything will be paraxial. If it's a marginal ray, I'll do indicate. If I give this distance, vertical distance, if